I would say overload. Okay? Okay, we finally finished with equals. And we thought equals was difficult. Okay? Let's look at clone. So, how many of you have used clone from class object? One person. So, for others, what do you think clone does? Sorry? Copies an object? So creates a new object, and when you say A is assigned clone of another object, you get a new pointer to a new object, right? Okay, to really understand clone, let's just understand memory representation. Okay, now let's talk of copying objects. So I have P1 is assigned new Cartesian point 200, 200. I say P2 is assigned P1. I say P1 dot set x 100. Okay. And now I say P2 dot get x equals P1 dot get x. The answer is false. P2 and P1 are just pointers to the same object. You can call me by any name. But if I change my shirt, I've changed my shirt. Okay? And by either name, I've changed my x coordinate. So I'm referring to the same object, but I just have multiple names. So now you see, all of you, a lot of you are thinking the other way around. So assignment is tricky. That's why you need a clone. Now you know we were not creating a copy. We were not creating a new object. Okay? So it's actually going to return true. So what do we want copied other than reference? Okay. So then the properties can be changed independently, and we might want to back up something. There's lots of reasons why you want to copy. So I go and say P1 is assigned new Cartesian point 200, 200. I say P2 is assigned new Cartesian point, and this is how I'm going to create a copy. I say P2 is assigned new Cartesian point P1 dot get x, P1 dot get y. I say P1 dot set x 100. Now, if I say P2 dot get x equals P1 dot get x, the answer is finally. Okay. So we didn't need clone. We can do our cloning. Okay. So why should some class define a clone method then? So I would have, supposing I had time, time is going to take the same time all cases. The question is how much code did you have to write? Here, who's writing the code? The code that uses Cartesian point. So you want a backup. You're one class. You want the backup of Cartesian point. I'm another class. I want the backup of Cartesian point. We both have to write this code. And if this was a string history, we both have to write the loop. Whereas if the class has that method, then every user of that class can just call that method. Every user doesn't have to go and define this clone. So, copied object can do the work. Okay, so rather than the copying guy, the one who wants the copy, the copied object can do the work, and that's why clone is defined in class object. It's protected, which means it's not really public. Okay, but let's ignore the fact it's protected for now. But if we didn't have to worry about that, we'd say P1 is assigned new Cartesian point, P2 is assigned P1 dot clone, and then you'd say P1 dot set x. And why am I doing point P here for P1 dot clone? So clone is defined in object. Object doesn't know about points, so it can only put the return value as class object. But we know that this is going to be of the same type. So we go and say point P1 dot clone. I say P1 dot set x 100, and I say P2 dot get x equals P1 dot get x, and I'll get false. Okay. So before you, let's confuse you. I create a bounded point. 75, 75, 50, 50. I say P2 is assigned P1.clone, I'll say bounded point here. I say P1.setX 100. I say P1.get upper left corner set X 200. Okay, so I've changed P1. If I say P2 is get X is equal to P1.get X, what should I get? Just as we expected. P1.get upper left corner get X, which we've changed here, equals P2.get upper left corner dot get X. The answer should be false. Marshall, what's it going to be? He's used clone. Okay. So we copied, but we didn't copy. Okay. And what's happening here? What do you guys think? When we copied, we created a new object, that's for sure. But what did we put in that new object? We put exactly the memory contents in the first object onto the second object. We just took those 4 slots, copied them, which means we copied the addresses of the sub-objects. Okay? Such an object copy is what we call a shallow copy. Just copies the memory. Okay? And when you want to copy the whole structure, we'll call that a deep copy. Okay? So there's shallow copy, there's deep copy, and we'll see in great depth what this means. Let's confuse you. I create a bounded point. 75, 75, 50, 50. I say P2 is assigned P1.clone, I'll say bounded point here. I say P1.setX 100. I say P1.get upper left corner set X 200. Okay, so I've changed P1. If I say P2 is get X is equal to P1.get X, what should I get? Just as we expected. P1.get upper left corner get X, which we've changed here, equals P2.get upper left corner dot get X. The answer should be false. Marshall, what's it going to be? He's used clone. Okay. So we copied, but we didn't copy. Okay. And what's happening here? What do you guys think? When we copied, we created a new object, that's for sure. But what did we put in that new object? We put exactly the memory contents in the first object onto the second object. We just took those 4 slots, copied them, which means we copied the addresses of the sub-objects. Okay? Such an object copy is what we call a shallow copy. Just copies the memory. Okay? And when you want to copy the whole structure, we'll call that a deep copy. Okay? So there's shallow copy, there's deep copy, and we'll see in great depth what this means. Going on. And what's really going on is that Java does a copy of the memory space it allocates for an object. Okay, so for bounded point, it allocated this space. 75, 75, address of the first upper left corner, address of the upper right corner. These 2 objects are in different areas in memory. Okay, and we have pointers here. So this is the space that actually allocated for that object. These objects could be shared by other objects too. So when it said, when it was trying to create a clone of this, it just copied that memory area. Okay, so there is a different slot for the primitive variables. I change this primitive variable, this one doesn't change. But as long as I keep the upper left corner and the upper right corner the same, and then I go and change one of the corners x coordinate or y coordinate, because the addresses are the same, values are shift. Okay, so this is graphically showing you what's happening. That I have a bounded point and another bounded point. They get copies of the primitive variables. The object pointers are pointing to the same object. If I go and change the x coordinate here, it's changing the x coordinate for this object. Okay, yeah. The object properties. What? So I had 75, 75, 16, 24. Okay? And then I had 75, 75, again 16, 24, because the new copy got the same pointers as the old copy. So I just copied that whole memory area. And so the pointers got copied too. Why was it not normal? That was all the heap. There was no stack there. In heap, things can go in any order. Okay, so there's allocated areas, unallocated areas, allocated areas, unallocated areas. You delete something from here, that becomes allocated now. So there's no order. And let's not look at my picture to indicate how, order might be. Just remember that heap, you take memory, you divide it into three areas. One area is where the program is. Okay, the program has to reside somewhere too, the script. One area is the heap area, and one area is the stack. Okay, and the stack area and heap, stack grows upwards and the heap grows downwards. I didn't show you this. Okay. So don't take that literally. I wonder which course you will learn that stuff much in detail. 411, does that teach the stuff? Sorry, 410. Does that? They may teach some of this stuff. The OS class may teach some of this stuff. The compiler class may teach some of this stuff. The compiler class will teach this stuff in most of it. Okay? But you know a little bit about it right now. Okay, shallow copy. So if it's not a shallow copy, it would be a deep copy. And what would that do? Okay, it would it go recursively down and copy the sub-objects. Follow the pointers so you get something like this. Okay? And, this is one issue that really is confusing about Java. If you've come from a non-object oriented language, I don't know, so which languages that you guys, I learned Pascal, which is an ancient language, but are there languages you guys have learned that are not object oriented? MATLAB? What happens when you have matrices in MATLAB? When you assign one matrix variable to another matrix variable, you get a copy of the whole matrix? You do? It's a deep copy, right? That's what happened in C. If you had a struct, which was a record, which had substructs in it, you assigned A's, assigned B, you got a full copy of the whole thing. Okay, unless you declare certain things to be pointers there. That's what happened in Pascal. So it's very confusing because we have here assignment, we have here shallow copy, which is clone, and we have deep copy. And where in other languages assignment is deep copy, here it is not, and even clone is not deep copy, and you've got to do special things to get deep copy. Okay? So you don't get deep copy, and a lot of, I know my grad student RAs have had trouble with their programs because they got confused about these things. That's why I want to go in depth in here. So let us go and, okay, I guess, so we're going to create our own deep copy. Java doesn't provide you with a deep copy. Okay? And we're going to use Java's clone to do a deep copy. So we're going to just use it recursively. We can have clone, call, clone, or something else, sub-objects. So there's an issue as to how do you even call clone. As it turns out, the clone method in class object implements shallow copy, but class object realizes shallow copy is not a very nice copy. It says, yeah, I'll give you shallow copy, but I won't, announce too loudly that I have a clone for you. Okay? And by not announcing too loudly, it goes and makes the method protected. We don't know what protected really means, but that means it's not public for sure. Okay? So you can't just call clone on an object from outside of it because it's not available, it's not public. Okay? But we're going to, we think we know what we're doing. We're going to create a deep copy. So we'll firstly go and make clone public. So if you've got something like Cartesian point, and you want the world to call it clone on Cartesian point, you override clone, and you don't do much in that overriding. You just say super.clone. Okay? But you change the signature. You made something that was restricted less restricted. That's something you can do in a subclass. Okay? You can take something that was restricted and make it less restricted. Okay? And that's not the whole story. Java really, is shy about advertising what's going on here. You have to also say that the Cartesian point implements clonable. Okay? Now you see two new concepts here. I say implements point, comma, clonable. What's the new concept you've seen here that you haven't seen before? I can implement two interfaces at once. Plus, every time you put an implement, there's a pain on you, right? That you have to go and add some methods. Clonable is an interface that has got nothing in it. So by saying you implement clonable, there's no new obligation on you. That seems crazy. Okay? And it is crazy, actually. Java just didn't have the right construct at that time. So it's really tagging the class as saying it's clonable. And at that time, it didn't have annotations. So this is really like when I say, look, the shape is not atomic shape. That's really tagging. It's an annotation. There was no annotation at that time, so they used things like that. I think you have a comparator. Comparator has methods in it. Comparable, I believe it has methods in it. Yes. So you have some obligation on that. No, there is no inherited method there. Here you have an inherited method that is not public. Okay, so there are two questions. Is it possible for an interface to extend two interfaces? And is it possible for a class to extend two classes? Okay, I'm generalizing your question. So what about the second question? Can a class extend two classes? That's called multiple inheritance. Theoretically you can, except that what do? You've got brown eyes from here and blue eyes from here. What eyes should you have? Okay? We don't know, and we still don't know actually. I mean, these things haven't been resolved. And, Java doesn't want to get into, people get very confused that, what the result should be. So, at least that's a theory right now. It's very frustrating because what if, I'm inheriting eyes and nose from here and there is no question of two eyes. Okay, I just can't inherit from two classes. So I got to cut and paste. So, all the cut and paste you guys did, even with inheritance, you have to do some cut and paste. That's life in Java. Okay? And so it's not as if that was a totally, unnatural exercise. Yeah, Sean? Yes, you can do for any two interfaces. But if you went and said, I'm implementing point and BMI spreadsheet, which, that makes no sense. But if I'm implementing point and BMI spreadsheet, I would have to have both the BMI spreadsheet method and the point method in. Okay, the first question we asked was, can a class extend two classes? We said no. Can an interface extend two interfaces? The answer is yes. Okay, so I can define another interface called Cartesian point that extends point and clonable. And then you would have me implementing only one interface. Okay, we'll get into this, I think, more later. But that's the quick answer. Yeah. So, what do you think? So what do you think is the interrelationship? Yes. A Cartesian point is a point. A Cartesian point is a point is a no. It doesn't extend it. Other things? Okay, so we're seeing many concepts here. So let's assume that we have done that for Cartesian points. Now I want a bounded point. And I want a deep copy. I want my clone to do a deep copy. How would I do it? Marshall? Okay. And then what would the deep copy do there? So this, the top level object calls copy on the sub-object. That's the recursive thing. That's what we want. Right? Now, Marshall is saying, don't use clone, define your own method. Why define your own copy method? So it's all messy stuff. It's another messy thing that's going on that would not go on with deep copy. So, since you've used it, can you guess? So one, you got to go and say clonable. Clonable doesn't have anything in it. I mean, it gets a little confusing. What's the return type of clone? If I override clone, my return type would have to be object. Can I overload clone? Can I have my own clone that returns Cartesian point? Not if it implements. Clonable has nothing in it. And with equals, I could do that, right? With equals, I could go and override equals and have my own parameters. With clone, can I overload the clone? So when you overload methods, the question is which overload method should be called? And the decision is made on parameters, not the return value. If you do the return value and parameters, it gets very confusing because Java is looking at the context to determine which one to call. And now what you're assigning to is where we don't know what the return type is, we don't know what the parameter type is, so the context doesn't give you enough information. When you can fix the return type, then you can use the context of the parameters. Okay, so for that reason too, you shouldn't do that, but you're going to do it anyway. And so this is what. So the question now is, how do I do a deep copy of a bounded point? And this is my bounded point, and I'm just reminding you guys that how bounded point is. It's got these constructors, it's got these upper left corner and lower right corner, and we will do something like this. Okay, we will not be good. We will override the clone, okay, because the clone exists and we can live with the clonable issue. And I say a new bounded point x comma y, upper left corner dot clone, lower right corner dot clone, and I'm going to cast this to a point. I'm going to cast this to a point. Why did I have to cast this to a point? Because it returns object, and bounded point expects what here? Points. And do we know that this cast is safe? We know it's safe. We give it a point. We know at this point it can't fail. So yeah, it's a pain to go and put these casts, and that's why you should probably have your own copy. I recommend that actually. But this shows you how we can live with flow. Okay? So you see the recursion here, that my clone here calls the clone method here. Okay, so clone calling clone is like having the recursive method. And then, when I go and say bounded point t1.clone, I say t1 set x, then I say t1 dot upper left corner set X 200, and now I'll get false here, and what will I get for the other one? Okay, finally it's working as we expect. We had to do some extra work, we had to define our own clone. Okay. So does this code work? Seems to, right? Can you run into some trouble? Well, we wrote the upper left corner's clone. We wrote the Cartesian point clone, but you're saying maybe some clone doesn't, some implementation may not give you the right answer. That's true. Okay, we wrote one, that was correct, but it's possible for somebody to write wrong. So whenever you're not guaranteeing the type, you're living dangerously. That's true. Actually, you're living dangerously for other reasons too. So I call it a recursive method. Clone calls clone. Then we write recursive method. It's very powerful, but it can be dangerous. Because, yeah. So in recursion, there's something called a base case, and if the base case is not proper, you can go on forever. So can this one go on forever? Yeah. Mm-hmm. Well, that's good. You're getting along the right line. So what if this upper left corner was a bounded point? You would just copy that bounded point. You're on the right track. Yeah. This is not just a bounded point, it was the bounded point I just had as a parent object. So I asked you guys to create physical structures, and the physical structure is very clear. There's a parent, children, grandchildren, great-grandchildren. And now what kind of physical structure would cause you trouble here? If, let's say what, child is the father of man. So if one of the grandchildren pointed to a parent, its parent. These are just pointers. You can just arrange them as you want to. Okay? So let's do messy stuff here. I create a new bounded point. So far so good. I got Cartesian point here. Then I say P1 dot set upper left corner P1. Okay, I can do that. P1 is a bounded point. Bounded point is a Cartesian point. This is perfectly legal. Okay, and then I said P2 is P1 dot clone, and you can wait a long time to get the clone back. Okay, and what's going to happen? Just keep going, and the whole you get two kinds of problems with recursion. A, it just goes on forever, and B, the memory gets full. And you get both of these problems. Okay? So this is infinite recursion. And what you get is a structure like this. One point is good, the other point points back to itself. Okay? And what did we have here? We had bounded point x comma y point clone. So it goes and says, okay, let me go and clone my child. So it clones one child, and it says, let me go and clone the other child. Creates this structure, says, let me go and clone the missing guy there. Okay, and my PowerPoint slide is not big enough. Memory is bigger, but still, I'll run out. Okay, so now you know maybe why, well, there's many reasons why object doesn't provide clone, but we see this problem with deep copy. At least the way we wrote it. Okay, questions? Get it? Yeah. What kind of parameter would you give it? Deep or shallow? So that's what SMALLTALK did. It had three kinds of clones: shallow copy, deep copy, and copy. The copy could be defined as shallow copy or deep copy, depending on the program, depending on the object. So what deep copy did was that it went and called copy on the subchildren, on the children. That copy could have been shallow copy or deep copy. Okay? So there are three methods possible, and if you want a deep copy, you just call deep copy. Deep copy will go and copy the structure, then go back to his children and say, call copy on that, and that copy could be shadowed. Okay, so I think that's my next slide. But what would you really like to have happen? I mean, we don't want to give up so quickly. Let's say we have, by the way, this kind of structure with an arrow pointing, with this kind so I have two kinds of structures here, this structure and this structure. Those of you who've done some data structures, I know some of you have. Can you tell me what is the difference between these two data structures? So this data structure is called what kind of data structure? For those of you who've done this, most of you haven't. That's why you need to do 410. Tree. This is not a tree, right? It doesn't have branches just going up, and it's got branches that meet back other branches. And what's this structure called? It's a looping tree. I have graph. Are those interesting data structures? So your internetwork is a graph. Now I'm pointed here, he's pointing back to me, and through circles. Your highways are graphs. Okay? There's a lot of interesting graph problems, like traveling salesmen that you might have heard of. Okay, we've got a bunch of connected cities. How do we optimize our route? And that's a very hard problem. And you can solve it, but it takes a lot of time. And so these are very interesting data structures. And it's not that we can just ban these data structures. Okay, so given a graph like this, and this graph, what you call loop, is called a cycle. Okay, so a tree is a special case of a graph where there are no cycles. And there's graph, there's directed acyclic graph, and there's tree. So when you have a child with multiple parents, okay, that may or may not involve cycles. We'll see some examples. But basically, the loops is what is called cycles. Okay. So what do you want to do? What do you want if by magic you could sort of create a nice clone? What should be a good copy of this? What should you really create? I mean, you're going forever. The other thing is to give up and say, hey, you've got a cycle, somehow detect a cycle and say, can't clone. Yeah. Okay. Or point to some other object that you can copy of. So you just copy about this point at the coordinate there twice? You copied this to here, 196. Make another copy of it that's exactly the same as 196. That's 2. So, sorry, you make a... Why do you want to create a second copy? You created this copy. Oh, no, you're right. You got this copy. Where should this really point? Back to this guy. Such a copy is called an isomorphic copy. The structure you create is isomorphic to the previous structure. That's what we want. Do you think Java provides such a facility? It would be nice, right? You can write a program to do so. Has anybody tried know about serializable objects in Java? Anybody heard that term? Anybody try to write an object to a file? You have? Just writing integers and strings. You can write whole objects to files. Sorry? In Comp 110? Somewhere else? So you wrote to a file and whole object. So how did you, if you wrote, how did you write to the file? What did you have to do? You don't remember. Some magic words you put? Okay. So, you know, when you create copies, when you want to save something in file, supposing you were to save this whole object in file and want to read it back, it's the same issue, right? And so Java does provide this facility, and for reasons I don't know, it only provides such a copy to file and network, but does not provide such a copy in memory. Okay? And so let's just go on so recursive structures are useful and make deep copy problematic. Link from child to parent often occur. Okay? So shallow copy copies the instance but not its components. Deep copy creates a new object and assigns deep or shallow copies of instance variables to copied objects. Okay? Yeah. It would be fine. Yeah, you would just be getting, you know, you would just get a copy of the memory content. Okay. It would point back to the original guy. It won't be isomorphic, but it won't run into an infinite recursion. Okay? So deep copy means that you have to copy, you don't assign but copy the instance variables, and there you can either do a deep copy or a shallow copy. Okay? And SMALLTALK, this is what I was saying, there's a copy, there's a shallow copy, there's a deep copy, and this is basically saying what I just said earlier, so I'll just skip it. So if copy is deep copy, this is what we're getting, and if copy is shallow copy, you get something like this. This is exactly the question you asked. Okay? And what we might really want is something like an isomorphic deep copy. And Java has got something called Java serialization. So just as you can implement the clonable interface, you can implement the serializable empty interface, which means there's no obligation on you. Just implement it. And then you can copy the thing to a file or network. So you say something like this: a Cartesian point implements a Cartesian point, comma serializable, just as we said clonable, except that this is now not in java.lang, so we have to go and import it. And then you can deep copy this object onto a file or to the network. So it creates a deep isomorphic copy. And I think this isomorphic thing is new, because earlier I once tried their copy and I went into a loop. So now, for some reason, again, I don't understand, they provide the copy to file, they will provide the copy to network, but not provide a copy in memory. So what I've done is written a little method that's available to you guys. You can use this if you ever want to. You say mist.deep copy object copied, and you'll get an isomorphic copy. And what I do is I just create a temporary file. I write to the file and read it back from the file. Okay, and I create an in-memory file, so you're really not going to disk. And so this is something that you could use if you really want to. Okay. Okay. So let's go and understand this copying a little better by seeing its application in an object editor. So, you know, I provided this deep copy not for you guys, because I needed it. And since I needed it, I figured, why not let everybody have it too? And I needed it because of automatic refresh. So, you know, when you guys go and change something, you go and move a line, it just moves an object editor magically. Well, hopefully it moves. Sometimes it moves, sometimes it doesn't. You'll have to fix the bug. Okay? How do you think that's happening? When you make a change to an object, how does the object editor know that what to do, that you've changed it? Yeah. So it could call all the methods again. And that was all right when you had primitive variables. But I mean, your structures get so long. And you're building these deep structures. That means I have to go and Destroy everything and recreate the whole structure. Okay, later I will tell you how to tell me what you changed. Then it will work nicely, much nicer, hopefully. Okay? So what do I have to do if I don't want to update the whole thing? And then, no, but if I refresh the whole deep copy, then again I'm doing the whole thing again. So now I've got to, by doing what? By comparing the two copies. Okay? Because every time I make a deep copy, and then when you go in, when you change something, I make a deep copy of the change, of what I think is a change object, and then I do a dip. So what's really happening, what's really going on is, supposing you go and change this 100 to 200. Okay, so I'm just looking at the top level object. This hasn't changed, this hasn't changed, this hasn't changed, so I might think nothing has changed. Unless I go and look recursively down, and to look recursively down, I have to go and know what was existed earlier too. So how does OE know that the value changed? All components of a boundary point have the same value if I don't look. So it creates an isomorphic copy when it first encounters an object. And it can do that only if it's serializable. And then supposing an operation is executed, it calls equals. It uses equals to go and figure out if the two objects are fixed. Now if your equals doesn't work right, if you don't have isomorphic copy, if you don't have serializable objects, then it's just refreshing the whole thing. Okay? And that becomes inefficient. Yeah?
Now, in my case, it's calling the object equals.
It's calling the equals.
Whichever way, if you so if you were to break the equal method, just think, because you're not actually using any method. If you break that, then you just make it say return null or.
You'll break your refreshes.
It'll.
Okay.
So that has to. Now, do you need to make sure that works to compare to? Because I haven't gone through and set the equals.
Yeah. So it's working inefficiently.
Okay.
You can make it more efficient.
Oh, okay.
But you make it more efficient and you have the wrong equals, it not work. I told you, optimizations, something doesn't work, turn off the optimizations. And there's a brute force approach. So, if objects and all of the descendants are not serializable, then no deep copy for efficient refresh. So if you either don't provide serializable, which you don't, or if you don't provide good equals, it's doing a brute force. Okay? Which is inefficient. And you can actually do that. You can you can make it serializable, you can define your equals, and you can see that it's being called. Okay, so you can override equals and set breakpoint in it to verify that it's called with copy. Okay, that's just to show you an application of this idea. Now let me go on to something that's apparently very different, but it's related. You guys ever try to print an array? You get something like this. Okay, I don't even know why they have this left bracket L. Anybody have a guess? Anybody told? But okay, this is kind of funny stuff, but what would you expect when you print an array? What do you expect to happen? You get the array elements, but Java doesn't do it. Can anybody guess why it doesn't do that? It's somewhat related to the discussion we've been having so far. I don't know why they don't have it. I'm just giving logic to what it is. Well, what does print do? It calls toString on the top level object. The toString on an object like an array can be overridden to call toString on the sub elements. Then you've got to figure out how to format it. But you can figure out some reasonable way to format those elements. And that can call toString on the subarray, and that will work out. But you're on the right track. toString would call toString recursively, right? So can I run into some trouble here? So what's the exact trouble I'll run into? Well, can you put an array into itself? I create an array, and I say recursive 0 is assigned recursive. It's an object array. Array is an object. I can do this. And I say println recursive, and I'll wait forever. Okay? So I don't know why they did it that way. I don't know why the left bracket L there exists. Maybe they weren't thinking at all. But if they were thinking, this is what they were thinking. Okay? So you get something like this. Okay. Other object operations. So you guys have seen equals. You've seen equals. You've seen clone. Hash code. You might have seen this when you use Eclipse. Okay, it has to do with hashing. Hashing is a very, very important concept in computer science, and you will learn a lot about this in 410. Okay, so it's like an internal address of an object, except it's a hash code, which is different. Other operations you might have seen, class object. Get class, which is when we look at instance of, you said how can we figure out whether it's exact class or not. So that's get class. Other things you might have seen. Wait, notify. Okay, when you do a dot, you see those. And we're going to look at threads at some point in this course, and we'll see what wait and notify mean in a very superficial way. If you really want to understand what wait and notify do, you have to take an operating system class. Okay, get class. And finalize. That's something I can actually explain to you what it does. So remember, objects get garbage collected. So I have Cartesian point, 2 Cartesian points, and then I make one P2. I say P2 equals P1, so you have now 2 guys pointing to the same object, and there's nobody pointing to this. This gets garbage collected. Before a object is garbage collected, you can the object Java calls the finalize method in it. Okay, so maybe that object has some files that are open that are referred to it by it, and it can then get close those files. So